Advanced Math Lesson 98, Change of Base and Contrived Logarithm Problems. So we're going to be using some more logs and natural logs to work with numbers that are in the log base other than e or 10. And it's a really interesting lesson because this is the same way that people used to do it a long time ago before calculators, because in order to do something like log base 5, they didn't have a chart for log base 5. They'd normally only keep charts for log base 10 or log base e, so they'd have to convert the problem into a form of log base 10 or log base e to solve it. That's enough history. Let's go into the problem. So the question is, how can we solve something like this? Log base 5 of 15 using log base 10 or log base e by rewriting it, i.e. without really using a calculator or using a chart. Instead of going to your calculator and then typing in 5 as the base, we could still do this using base 10. So the way we do this is first we rewrite it. In order to figure this out, we're just going to set it equal to an unknown, right? So we'll say x. So log base 5 of 15 is going to equal x. We don't know what that is yet, but we do know it's going to equal that. So from there, we would rewrite it using our rules of logarithms, and we'd take the base to the power of x. So then we'd have 15 is equal 5 to the power of x. From here, the way that we get it to work in logs or natural logs is we'd just take the log or natural log of each side. So we'd rewrite it as log of 15 equals log of 5 to the power of x, which, if you remember, this right side can get rewritten with x as a coefficient. So it's x times log of 5, and this is in base 10. So that's how I've converted to base 10. From here, now all I have to do to solve for x is divide each side by log of 5. So that cancels, and then I've got x is going to equal log of 15 divided by log of 5. So now, since these are both base 10, I can go to my calculator, type in log 15 divided by, log 5. And I get 1.682, which I'm just going to round to 1.68. So my unknown is 1.68, or, well, actually 1.68 equals log base 5 of 15. All right, and then we can go ahead and test that if we take our calculator and then we go, hold on. How did I do this? We did log base 5 to the power of x equals 15. So we'd have to do, hold on, my brain just shut off on me. Okay, never mind. I'm not seeing I thought there was a way that I could do base 5 on a calculator, but I'm not seeing it. Maybe it's on the other one. Okay, no matter. This is the right answer because the book said so. That's it for change of base. Again, when they give you a logarithm with a funny base, set it equal to an unknown, rewrite it as an exponent, take the log or natural log of both sides, and then solve. So that's that. Now we're going to talk about contrived logarithm problems. I'm just going to put an example down because these can be they can be a pain to explain. So let's start with an example. So if we have the log base 10 of x squared, and that's equal to the log of x to the second power, these are not quite the same thing. Well, they're not written the same way, right? And so if we were going to solve this equation for x, this is what we'd call a contrived logarithm problem. The reason why it's called contrived is because there's two ways to solve it. If you use one of the ways, you can exclude some of the answers. Kind of like if you remember on our old trig problems, we'd sometimes get some extra answers that aren't possible, like for tangent and stuff like that, so we'd have to filter those out. In this case, we're not getting something that we would filter if we solve it a certain way. So I'm just going to focus on the factoring method. If we use a factor method to solve these contrived logarithm problems, we'll never miss any of the possible zeros or answers to the problem. Using a factor method, just like if you remember back from algebra, we're just going to set this equation equal to 0. So, actually, do I need to rewrite this first? Nope. Okay. So we'll set this equal to 0. This would be like the x squared term. This would be like the single x term, because I can rewrite this one as a coefficient. So the left side I'm going to turn into 2 log of x. The right side, I'm actually going to subtract log base 10 of x squared from each side. So now I've got, actually, you know what, that's then, but then my lead, no, hold on, let's do this. We'll keep the right side the same and we'll subtract from the left side, so that way we still get a positive. So we'll minus 2 log base x from the left side. And now I've got, if I rearrange it again, I've got 0 equals log of x squared minus 2 log of x. So from here I can use zero factor theorem. And I'm going to be using common denominator. So the common denominator to factor out here is log of x, and that would get multiplied by log of x minus 2. Okay, so here I can look for some zeros or some answers to the problem. One of those is going to be this one by itself. We would have log of x is equal to 0. So that one is actually going to equal 1. So if we take 10 to the power of 0, right? So if we plug this one in and we have x equals 10 to the power of 0, any number to the power of 0 is equal to 1. So one of my possible answers is 1. Oops. X equals 1. Now the other one is if I take log base 10 of x minus 2 and I set that one equal to 0, I would have to add 2 to each side. So now I've got log base 10 of x equals 2, bringing the 10 up to the power of 2. So now I've got x equals 10 squared, which means that x is equal to 100. And these are my two possible answers. Now the side effect of doing this a different way, if you started all the way up at the top, the other way, or the alternate way, would have been at the very beginning to write log x squared is equal to log of x times log of x, and then tried to solve it that way. That way leaves out a possible answer, so we'll stick to this factor method. How much time are we at? 7 minutes. I'll do one more example of the contrived logarithm problems because they can be a little difficult. Ooh, this is a tough one. Okay. Let me move this paper. Okay. Now this one, we have log to the power of the square root of log base 10 of x. That equals 10 to the power of 8. Now, this exponent might scare you because it's a square root of a log. Don't worry about it. It's just like one of our normal exponential log problems. If we're trying to solve for an unknown in an exponent, we usually start by taking the log or the natural log of each side. I'm going to go with log since this problem has already got a logarithm in it. So if I can rewrite this as log base 10 of x to the power of the square root of the log base 10 of x, and that equals the log of 10 to the power of 8. I can rewrite these exponents as coefficients, which then makes it easier to solve. So now this becomes the square root of log base 10 of x times the log of x, and that equals 8 times the log base 10 of 10. Cool thing, log base 10 of 10 cancels itself out. So now that just equals 8, which means this is a little bit easier to solve because I can rewrite these, well, I'll rewrite this exponent here. The square root of log x can just be written as log of x to the power of 1/2. All right, so I'm going to use a fractional exponent there instead of the radical. And then if I multiply that by the log of x to the power of 1, I add those up and I get log of x to the power of 3/2, and that has to equal 8. Now if you remember here, we would take the base of 10, bring it over, and then we have x to the 3/2 equals 10 to the power of 8. Right? Wait, did I just break a rule? Hold on. I think I broke a rule. No, I just went about it the wrong way. I should have noticed with the denominator 3/2. Okay, let's backtrack. Back over here. I've got log of x to the power of 3/2, and then 8 is also a number in base 2, so I can rewrite this. How can I rewrite 8? Actually I can take 8 to the power of 3/2, or 2/3 maybe? Yeah. So I take 8 to the power of 2/3, and then I take this to the power of 2/3, what happens there is the exponent cancels, and then 8 to the power of 2/3 is just 64, the cubed root of 64, which is actually equal to 4. So now I've got log base 10 of x equals 4, which means this is 10 to the power of 4. I wonder if I could have solved it the other way. I don't know. That seems like it might have been too much work. But 10 to the power of 4, which is just 10,000. And that's it for this lesson. If you guys have any questions, let me know on the school website, and I'll see you in class.